Hello, this is HKMath. At least that's what I like to call myself when I'm busy having fun with mathematics. Today, I'd like to solve a real-world application of a quadratic equation. And I'd like to solve this equation by completing the square. Now here's our problem. A ball is thrown straight up from 3 meters above the ground with a force or velocity of 14 meters per second. When does the ball hit the ground? There we go with that. Hit the ground. Hit the ground. The hit the ground implies a height of 0. Remember, the initial height is 3 meters. So I'm going to circle the 3 meters, and that is h sub 0, or the initial height. And then let's look at the velocity at which the ball is forced upward. The velocity is 14 meters per second. So this is the initial velocity, v sub 0. Then we are looking at the height when the time when the ball hits the ground. So we're looking for a height of 0. And let's see, have we covered all of our parameters? Let's look at the vertical motion formula. H equals a negative gt squared plus v sub 0 times t plus h sub 0. The height of the ball is going to be 0 because it's hitting the ground. The force of gravity on the ball moving it downward is a negative 5. So that's the g, plus 14 is the velocity times t, plus h sub 0, which is 3. I'm going to rewrite that so it's easier to read. A negative 5t squared plus 14t plus 3 is equal to 0. Now, in order to complete the square, we're looking at our A. Here's our A. We're looking at our B. And we're looking at our C term. Some call that general form, some call that standard form. We are going to move C to the other side so that we can get a perfect square on the left and numbers on the right. So let's do that. A negative 5t squared plus 14t, and I'm adding a negative 3 to both sides. We like our A term to be 1, so I'm going to divide the whole equation through by a negative 5. So we get t squared minus 14/5 t equals a positive 3/5. We are going to complete the square. by adding some number here. And because we add that number here, we must also add it over here. So off to the side, I'm going to take half of the linear coefficient. So that's a negative 7/5, and I'm going to square it. And that's going to give me 49/25. I'm adding 49/25 to this side, left, and I'm adding 49/25 to the right. Now, I'm rewriting, and this is the whole purpose of completing the square, is to rewrite the left member as a perfect square. So it's t minus that same 7/5 that you got when you took half of the linear coefficient and you square it. Now you are being asked to check this, and you will see that if you square t minus 7/5, you're going to get t squared minus 14/5 t plus 49/25. And that's going to equal 3/5 plus 49/25. I want a common denominator, so I'm multiplying numerator and denominator by 5/5. So we get 15/25 plus 49/25, which is equal to 64/25. Now this is what we did all of this for. We have a perfect square, so we now can use the square root method and take the square root of both members. So I'm going to take the square root of this side, and I'm going to take the square root of this side. And I end up with t minus 7/5. Note the square root negates or gets rid of the square. And we get plus or minus. The square root of 64 is 8. The square root of 25 is 5. We now are set up to get two roots or two solutions. We add 7/5 to both sides, and we get 7/5 plus 8/5, and we get 7/5 minus 8/5. So we have two time periods that works here. We get t equals 15/5, which is 3 seconds. Our second time would be a negative 1/5. And we don't know what that would mean in terms of time. A negative 1/5 does not work. So we call that an extraneous root. It works mathematically, but not for our real world problem. So we disregard one of the roots because it is negative, and we keep 3 seconds. So you have now gone through completing the square, and I'd like to say very quickly that this process is often used, completing the square is often used to factor. And when you're working with the conics in Algebra 2, so it's a process that you're going to need later. And those conics are the parabola. It helps you find the vertex. It helps you find the center of a circle, the center of an ellipse, it also helps you when you're graphing your hyperbola. All right, we have finished completing the square. Thank you very much, excuse me, for your attention. See you next time. Bye now.